So today we're going to do this pretty interesting Aime problem. This is from the 1989 Aime, and it's the second problem. So this is how the problem goes. 10 points are marked on a circle. So you got a circle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points on there. How many distinct convex polygons of 3 or more sides, because a polygon has to be 3 or more sides, can be drawn using some or all of the 10 points as vertices? So in other words, here, let me put it on the other side. Let me put the cap on the pen. So if we got these 10 points over here, how many different polygons can we make by connecting these points? You connect this point to this point to this point to this point to this point. That's one 4-sided one. You can connect all of them, as which I've done here, to just create one 10-sided polygon. You can connect just 3 of them, this one, and this one, all together. So in order to count these, I mean, they're going to be a lot. They're going to be in the hundreds. We can't just count them all individually. So we're going to be using some combinatorics in order to tackle this problem. So first, think of it like this. What makes a polygon? Well, a polygon means that it's going to have 3 or more vertices, and the vertices have to be from these vertices right here, these points right here, from these 10 points. So let's see. Let's make this in cases. So 3-sided polygons, 4-sided, 5-sided, all the way to 10-sided polygons. If we want to make a 3-sided polygon, we're going to have to take these 10 points and choose 3 from them to connect all of them together. In other words, that's just 10, choose 3. We have 10 points, we're choosing 3 of them. 10, choose 3. That's how many points we're going to choose out of this. Now what about 4-sided polygons? Well, it's the same thing. You got 10 points, and you have to choose 4 points from them to get all those polygons. So we can add 10, choose 4 more polygons. And this is the case for 10, choose 5, 10, choose 6, 10, choose 7, 10, choose 8, 10, choose 9, and even 10, choose 10. You have 10 polygons, you choose 10 points. Well, that's only 1, but for the sake of visualization, we'll just write 10, choose 10. And this should give us our answer. We find all 3, 4, 5, 6, 7, 8, 9, and 10 polygons we can make from these 10 points. So this is our answer. Now, how do we calculate this quickly? You could technically calculate this, then this, then this, all the way to 10, choose 10, but that'll take way too much time, especially in the Aime. This is just number 2, so there's definitely a faster way to solve this. Well, we can use this identity. I'll write it right here. N choose 0 plus n choose 1 plus n choose 2 all the way to n choose n is equal to 2 to the power of n. Now, I won't go into the specifics on why this is true. You're going to have to use Pascal's triangle, the hockey stick identity. There's a huge rabbit hole from this identity that you can look into. But for now, we're just going to use this identity for this problem. So we got n choose 0 plus n choose 1 plus n choose 2 plus n choose 3 all the way to n choose n equals 2 to the power of n. So we almost have this over here for 10, n equals 10, but we don't have 10 choose 0, 10 choose 1, or 10 choose 2, but we have everything else. So we can say that this right here is equal to 2 to the power of 10, but we have to subtract something. We have to subtract, well, we don't have 10 choose 0. We don't have 10 choose 1. And we don't have 10 choose 2, so we subtract that also. 10 choose 2. And that should be our final answer. So let's calculate this. 2 to the power of 10 is 2, 4, 6, 8, 10. Sorry. Not that. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. And let's see. 10 choose 0, well, that's just 1. 10 choose 1 is just 10. You got 10 points. How many ways can you just choose 1 point? Well, that's just 10. And 10 choose 2, which you can, 10 choose 2, I'll just write over here, 10 choose 2 is the same thing as 10 times 9 divided by 2. Quick thing over here, n choose 2, any n, is equal to n times n minus 1 divided by 2. So we solve this, we get 45. So minus 45. And now we just have to solve this. 1024 minus 1, 1023, 1023 minus 10, 1013, 1013 minus 45 is, let's see, just so we don't have to, make any silly mistakes. 10 and, oops, yeah, it is 13, so we got 8, 6, 9. 968. And that is our final answer.